हेलो माय नेम इज़ जोसेफ अहमद एंड जो हमारा ऑब्जेक्टिव है वो है मेंटेनेंस कॉस्ट रिडक्शन थ्रू प्रिडिक्टिव टेक्निक जिसमें हमारे पास company has a fleet of devices transmitting daily telemetry reading and they would like to create a predictive maintenance solution to proactively identify when maintenance should be performed. So this approach promises cost saving over routine. So let's मैं अपने आप को method share करता हूँ. What is the method which I have followed from the data? So obviously there is a predictive maintenance data set जिसमें we have a devices and other metric and a column of failure. That means there is about more than 1 lakh devices and उनमें से कितने fail हो रहे हैं with the integer value of 1 or 0 only. Uh, तो most likely ये जो सारे devices हैं we have to propose the idea of data cleaning and we want to provide ED analysis जिससे की वजह से it will help us to identify and categorize the data which is hard to understand by eyes. Further, we would like to propose another very important step, univariate non-graphical. Univariate non-graphical analysis involves summarizing the data using summary statistics, जिसके वजह से mean, median, mode, and standard deviation, and जिसकी वजह से that can help identify trends and outliers in the data. Then we have a multivariate non-graphical. So this will help us visualizing the data and can give a very insightful information uh, that really that is a procedure usually followed by all the machine learning predictive model developers. Uh, then we will go through and check for duplicate values and null values. Uh, then we come across the data transformation technique, then provide normalization of the data, and so on. So usually the libraries which I imported are pandas, numpy, cpon, and matplotlib, pyplot. Cpon is very useful. Matplotlib for visualization and pandas for manipulation of data set, manipulation of data frames. So just we input quickly the predictive maintenance.csv, which is imported by the organizers. So we quickly check the shape of the data, which is very quite large. We need to understand more deeply. We need to run ED analysis, quickly getting the summary of the data. That means that all um, other than date and device, all other are integers type, data type. बाकी जो है these are object, date and devices. So इसमें क्या है जो हमारे पास जितने भी डिवाइसेस हैं उसमें एक जो हमारे पास रिकॉर्ड है उसके अंदर कंपनी बार बार विद टाइम चेक कर रही है रिकॉर्ड कर रही है कि कितने कितने डिवाइसेस और उसके हिसाब से जो ऑल डिवाइसेस हैं वो बाद में भी जो फेल होते रहेंगे और जो अभी सरवाइव कर रहे हैं वो रिकॉर्ड होते रहेंगे. सो दैट दैट विल जो डेट है हमारे पास कॉलम वो हमें काफ़ी हेल्प करेगा टू जो डिवाइसेस सरवाइव कर रहे हैं उनको जो डिवाइसेस किस टाइम पर फेल हो रहे हैं सबसे ज़्यादा उनकी लास्ट टाइम उनकी वर्किंग टाइम क्या थी that will help us to understand and that can also become a very important attribute uh, in our before deploying the model but so it will have तो हम इस feature engine के through इस दो features को ऐड कर लेंगे. पहले तो यही क्या दैट कितना एक डिवाइस कितना एक्टिव डेज काम कर रहा है द अदर डिवाइस दैट कैन दूसरा जो है दूसरा आई विल जस्ट गो थ्रू इट आई डोंट सो हमारा जो डेटा सेट है उसमें हमारे पास फेलियर के अंदर सिर्फ दो वैल्यूज हैं यूनिक वैल्यूज 0 and 1 दैट मीन्स 0 फॉर नॉन फेलिंग एंड 1 फॉर फेलिंग एंड हमारे पास जो यूनिक डिवाइसेस है वो है 1169 डिवाइसेस दिस मीन्स हमारे पास 1169 डिवाइसेस हैं और इसमें कितने डिवाइसेस फेल हो रहे हैं वी जस्ट क्विकली रन अ कोड वैल्यू डॉट वैल्यू काउंट तो हमारे पास 106 डिवाइसेस फेल हो रहे हैं आउट ऑफ 124 और 124,000 जो हैं ये not unique devices. These are repeating. They have identical devices as well. So कुछ ऐसा हो सकता है कि डिवाइसेस जो हैं वो दो तीन बार फेल होके भी वापस आ गए हो मेंटेन रिकॉर्ड करने रिपेयर्ड होने के बाद सो एक डिवाइसेस भी तीन बार फेल हो सकते हैं सो देर इज अ तो इसका मतलब 106 बार टोटल फेल हो रहे हैं but not for unique devices. So one device can fail simultaneously, quick more than one time. So we just need to check. So the important thing which we came across is to run data visualization. इसमें हमें mm, yeah yeah the yeah to before making to understand that how much devices are running कितना काम कर रहे हैं एक devices we need to we already have a date column in तो we need to just enhance the quality of date so जो हमारे पास date है उसको पहली लाइन में हमने इसको date time में कन्वर्ट कर दिया है देन द सुपीरियर लाइन जो है उसमें हम कितना मंथ वो काम कर रहे हैं वो मंथ में कन्वर्ट कर दिया है बाय द डेट कॉलम and now we have two columns more like one is date where one is giving the number of month devices uh, is last recorded and the total number of active days the devices are working on and इससे ये भी पता चल रहा है कि by this column date it's very essential and very useful column. The values it is giving us, it's showing that by the first month we have more unique devices working on, and by the last month we have a very less devices working on. Like this means that कि जो last month में है बहुत ही कम डिवाइसेस सरवाइव कर रहे हैं और उनकी एक्टिव लाइफ बहुत ज़्यादा है बाकी सब डिवाइसेस और जो फर्स्ट और जो मिडल में है लाइक 5 से 6 मंथ के बीच में इसमें जो डिवाइसेस हैं हमारे पास वो एवरेजली जो पहले मंथ में है उससे ज़्यादा एक्टिव डेज हैं उनके और वर्किंग डेज हैं और जो लास्ट में है उनसे थोड़े कम वर्किंग डेज हैं इसके बीच में इससे ये पता चल रहा है कि डिवाइसेस आर डिक्रीजिंग ओवर टाइम ड्यू टू फेलियर ऑफ डिवाइसेस सो अब जो स्टार्टिंग ऑफ हमारे पास सिर्फ जनवरी से एक ट्रेंड हमारे पास सिर्फ 1 ईयर का डेटा है इसका 1 ईयर रिकॉर्ड है जिसमें हमारे पास डिवाइस वर्किंग कर रहे हैं और ख़त्म हो रहे हैं एंड हो रहे हैं बाय द एंड ऑफ द ईयर दैट इज दिसंबर सो नाउ वी हैव two new features like month and active days जो है I'm going to discuss here here the feature I'm talking about active days like the amount of the working days of a device इसको बनाने के लिए पहली लाइन में it can also be इसको तो मैंने कन्वर्ट करा है यहाँ पे ये मैंने इसको ऊपर ही बना दिया था इसका मैंने डेटा टाइप चेंज करा था आई विल टॉक अबाउट इट लेटर क्या अरे हाँ यहाँ पर मैंने ये रहा ओके so we were getting a feature based on date so there now we have two new features added into our data set that is month और that is active days so we can see that जो device क्या 11th month तक काम कर रहे हैं they have 305 active days this means that they survived longer than other devices now quickly just yeah so we have df2 data frame 2 that means that we have merged the first data frame and the other data frame that including all new features. So we have merged two files and call it as assigned it as a df2. Now the, we will come to our natural process before deploying the model. We need to transform the data, and we can run an we have run an analysis and we check that here we can check that about 50% about any standard deviation of the metric one is about a very large number. Uh, and metric 2 is also having a large number. Other we can see that it's 20 about 25% quarter and 50% of the value, 75% of the maximum values are very less than first one. Third one is also less than in comparison to metric 1, and metric 4 also are less, having a value very less than metric 1. Metric 5 is similarly very small number, having a very small number. 6 is having a very large number of values. 7 and 8 and 9 are also less comparison to 1. So the metric 3, 4, 5, 7, 8, 9 are having a very small value, so it would be useful in our analysis, in our data training. So we will convert it into categorical data. This column will be turned into categorical. Here I have shown that जो devices है, we have filtered the value is equals to 1. So जितने भी devices की value 1 आ रही है उसको मैंने sort कर दिया है by group by feature और by group by इससे इसको बाद it get easier to show to learn that the trend of the devices are decreasing over the time, and this red dot indicates that ये जहाँ पर devices fail हो गए हैं exact टाइम पर, एग्जैक्ट डेट पर। और ये जो डिज़ाइन है आई डिड another project on medical cost analysis. उसके अंदर I learned how to make that, how to plot this type of graph exactly. So yeah, to make it more obvious to get confidence, I just quickly go through that number of devices that we have are unique devices are having 1169, and by the last of the day by the last जो survive device करे हैं वो है 31, जो total fail हुए हैं वो है 106, और जो removed हुए हैं वो 97.35, and percentage of devices with respect to total record is 0.09. मैंने इसका पाई ग्राफ भी ऊपर दिखाया था, एंड परसेंटेज ऑफ फेलियर जो है वो है 9.31 परसेंटेज फेलियर 9.31. सो ये बहुत इम्पोर्टेंट ये बहुत इम्पोर्टेंट कोड है यहाँ पर. इट गिव्स अस दैट जो हमारे पास डिवाइसेस एज कंपैरिजन टू यूनिक डिवाइसेस 1169 डिवाइसेस, इनमें से जो डिवाइसेस फेल होके वापस ठीक होके वापस आ गए, ठीक होके वापस आए हैं, या वो ज़रूर एक बार फेल हुए हैं, और तो आई सो इट इज गिविंग अस दैट तो मैंने इसको ग्रुप कर हाँ, फिल्टर डिवाइसेस विद नो जीरो फेलियर लास्ट एंट्री इज नॉट इक्वल्स टू 1. सो इसमें से ये एक बार फेल हो चुके हैं, और हाँ, लास्ट फेल जो हुए हैं इस बात को सच्चाई है, और इनकी जो लास्ट डेट रिकॉर्ड करी गई है एंड दिस टाइम इज गिविंग है. तो इसके अंदर कितने यूनिक हैं? 106 डिवाइसेस आर 106 devices are failed. So in case failure devices, so these are the record of the failure devices. Uh, we can also मैं रिकॉर्ड कर रहा हूँ तो we can also find out कि इसमें से यूनिक डिवाइसेस कितने हैं. अगर यूनिक डिवाइसेस निकल कर आ जाएंगे तो we can see that कि कितने devices वापस भी आए हैं. Hmm. So let's go just quickly. We need to change the data type into numeric integer type, uh, all the objective, and then we need to convert metric 3 for all the small values columns into objective data set data type, and then just we need to transform the data quickly. Hmm. We need to before deploying the model, thus the pre-processing stage is very important. We need to scale the data. uh, you can quickly see that that metric 2 metric 1 has a distributed data, and logometric is distributed over between 15 to 20, and the range, and this is the plot of metric 2, skewed distribution of metric 2, which is highly skewed over. We need to scale that, and similarly for metric 6, it is highly skewed. So just quickly run the standard scale by importing standard scale from scale and preprocessing for metric 1, 2, and metric 6. We can see that now our data is scaled over small numbers. So yeah, we need to also convert our active working days into numerical types, so integer type. And also, date also needs to be converted into integer type. Float type, object type. So it won't become a barrier when we were splitting X test and Y test. Hmm. So yeah, now just split the data feature X and Y. तो हमारे पास जो obviously we need to the target variable is Y is failure, and बाकी सब जो होंगे that comes into X value. We assigned all to X value except failure, and failure into assigned to Y. Just so now our target value has only two unique values, 0 and 1. So logistic regression is the ideal way. Uh, my first option, let's deploy the model. We can see that it is giving us accuracy score of 92%, and hyperparameter which I have included is Newton CG. That also increase our accuracy rate by 1%. My the most common and very high best model in my experience and overall is random forest. I deployed the random forest as well, giving random forest classifier, which giving us accuracy of 93% higher than logistic regression with the hyperparameter. That, so it is giving us, we have a precision call of 93%, F1 score of 0.96, and accuracy F1 score 0.93%. So therefore, it's not a bad result. Yeah, the feature which is very important in our the feature was very important to predict the model was metric 2. Yeah, it can be and active days. So the feature active days was very important as and we can also thought intuitively that the number of devices which are working uh, um, the number of devices which are working tends to fail more than the devices which are working less. And metric 2, we can see that it's very useful in determining the model. So metric 2 has the highest importance all features. Metric 8 has the second highest importance feature. There is a metric 8 was removed because it was a mistake. It was a duplicate value, so I removed it. Uh, when I included by mistakenly uh, in the data frame after predicting the metric 8 comes to be the second highest important feature in predicting failure. But I just gone back and removed the data set from the data set as it was a duplicated value. Uh, okay, yeah, okay. Let's go quickly to the learning curve graph. The learning curve, we can see that as the number of training examples increases, our training curve, uh, uh, the performance of the machine learning model over time as it learns from the more data. Uh, so So the training curve starts at a highest performance, low perform starts at the highest performance, and it decreases as the amount of data is very small and expected because it's easier for the model to fit to a smaller set of data. As the amount of data is expected, it's harder for the model to fit into the large set, and we can see the co-validation score. The data is neither overfitting nor underfitting. It is linear. Uh, so our observation is that accuracy on the random forest is the highest, demonstrating the robust performance in predicting device failure. Uh, Overall, this project illustrate the machine learning techniques in predicting device maintenance failures and underscores the importance of feature understanding. Uh, Thank you.